So, Algebra 2, here is another example involving compound events. So, I think we have 1,200 students, so fairly large or average high school, about 4A. And at this high school, they surveyed the entire student body to see who had seen the latest Star Wars movie. I have no idea why. And 360 of the students said, yeah, we've seen it. I don't know how many of them liked it. I certainly didn't like the latest one.
I liked it.
Did you see that one scene?
I'll tell you why soon if you want to hear about that, but you know, that's another conversation. So 360 of the kids at this school had seen it. 270 of them were seniors. So what do you guys think based on that information? We might need more, but based on that information, what are the two events in question? You could start looking at the actual questions I ask you to decide what the events are, or you could just kind of think about what are the two possible kinds of qualities or conditions that I'm interested in.
Did they watch it?
Did they watch it, and
what grade they're in?
And what grade they're in, perhaps, and specifically what grade am I really interested in, senior or not, right? Now I do have some underclassmen throughout these other questions, but if you do more than two events, it gets more complicated. I think in your assignment I gave you one problem that has 3 events, but they kind of like set up the Venn diagram for you, so it shouldn't be that hard. In more advanced classes, we do them with 3 or 4 events, but you know, trickier. Okay, so to get my events, do you guys think, first of all, are they mutually exclusive or are they inclusive? Do they have some overlap or not? Are there going to be some seniors who've seen the film or not? I'm thinking so. So before I even get numbers on that, I think that these events definitely do overlap. Being a senior and having seen the film. So do I have enough information to fill in my diagram and answer these questions yet?
No.
So I know in the universe there's 1,200 kids, okay? I know 360 are total for this bubble, and I know 270 are the total for that bubble. But I haven't been told anything else. So as it stands, since we're assuming some seniors saw this film, I'm sure they have, we don't have enough information. They could give you that final piece of information in all kinds of different ways. So, I don't know, let's say that there were 100 underclassmen who had seen the film. I think that'd be one way to give it to you.
Yeah.
Or they could tell you how many were both seniors and had seen the film. There's all kinds of ways and variations, so you should be able to handle any of those. Does that make sense? But you need one more piece of information. So I'm going to say there were 100 underclassmen who watched the film.
It doesn't add up.
Does it not? Does that not make sense?
Because it's 360 that have seen the film. 270, that leaves you with 90.
So it needs to be 90 underclassmen, not 100.
Yeah.
I'm not seeing it.
So there's 360 have seen the film.
I'm thinking...
Oh, because seniors attending,
I
not
think-
seniors that have seen the film.
I think I'm okay.
Attending the school, okay.
Good question, though. It's a good question.
That looked a little...
So 100 underclassmen have watched the film. Only 100, right? So I think where would that 100 go? Is that going to be in this part of the senior bubble, in the middle, or in this part of the film bubble? It's going to be in that part of the film bubble. Because those are people who've watched the film, but they're not seniors. So they stay outside of the senior bubble. Sweet. So now that we've got that, I think we can figure everything else out. So how many people are in the middle then?
360 or 260.
360 had seen the film, so this is total 360. So if that's 100, what's left? 260. And if I know that,
Yeah.
how many other seniors are there? Only 10. Well, Star Wars is popular at this school. What can I say?
Well, not the underclassmen.
Hey, seniors have cars. More than underclassmen.
I
I
have
don't know.
parents who like Star Wars.
Okay, so how do I get the remaining students who've neither seen the movie nor have senior status? 1,200, can you guys do that for me? That's pretty easy. What do we got? 360 and 10 is 370, so what's 1,200 minus 370? Is it 830? Double check me.
Math.
I think so, but okay. Once we've got a complete picture, and that refers to whether you've got a Venn diagram for a compound events with an OR type of probability, whether you've got a tree diagram for independent versus dependent events with that kind of probability. If you've got the picture, like the rest of the problem shouldn't be that hard. Picture is where it's at, you know? So there's all kinds of ways we could do this now. Let's look. So a student, what's the probability a student was a senior or saw the film? You could do that a few different ways. You could go the probability student or film, but I really want you to write it in symbols at least that far, okay? Now you can use the rule that we did yesterday where you go probability student plus, since that's the way OR works, probability film. And we agreed there was an overlap, definitely, right? So we don't want to count that twice, so we'll have to subtract the probability of both to avoid counting twice. You can do it that way, and you can find this number, you can find this number, you can find this number, and you can put them together. But I would argue you can also do it another way with a picture, and that's pretty nice. So I'm going to do it both ways on this first one, and then I'll kind of pick my favorite for the rest, okay? So what's the chance that you're a student at this school? Excuse me, this shouldn't say student. What should this say?
Senior.
Should say senior. Nice. Because everyone's a student, so that would be kind of silly. We would get 100%, right? So the probability you're a senior is how many were seniors? 270? How many had seen the film? 60. And we really need the diagram to figure out the both. And you can get that. So what is that? Can you guys use your calculators and tell me?
That's a number.
Is it 300 or 360?
No.
I don't need a calculator. That minus that's 10, plus that's 370. Okay? So
30.8%.
that's one way to do it. 370 out of 1200, which is like 28%. Great. Another way to do it is just think and use the diagram with more common sense. What's the probability a student was a senior or saw the film? Just go through here and pick the people who count. Do these people count, these 10 seniors? Yeah, because they're seniors. These people count that are seniors and have seen the film? Yeah, because they're one or the other. They're both. And do these 100 people who are underclassmen, even though they have seen the film, count? Yes, because they've seen the film. 10 plus 100 plus 260, I think you'll find is 370. Done. There's another way to do it. I think it's important to know how to do it both ways. Let's look at this one. So what's the probability a student was a senior given they'd watched the film? This one has decreased the sample space. There's a condition. So I'm going to write it out. Given they had seen the film, what's the chance they are a senior? When you see given or conditional statements, whether they use the word given or some other kind of phrase, you always want to write that down right away. I think that really helps. So now I know that the sample space is not all 1,200 kids, it's only those people who've seen the film, which is how many? You can get it from the table or from the numbers. I think it's 360. How many of those people were seniors? I think the picture makes that really nice. Here's the 360, and here's the people that were seniors out of that. So it looks like about 2/3, but I think that's a little bit more than 2/3, isn't it? What is it? Maybe it's not. 72.2. Yeah, a little more than 2/3. Sweet, there we go. So that one was a little simpler than that one, and this is one of the SAT's most favorite problems I've noticed recently. They have all these in there. Okay. What about the chance that a student was an underclassman or had seen the film? So again, I'm going to write it in symbols. Probability they were an underclassman, so anything except a senior, or had seen the film. Now we could do this by the rule, and you should know how to do it by the rule, by going one thing plus another thing minus the overlap. But this time I'm just going to do it by looking at the picture, just so you have a variety of strategies and you can pick your favorite. So, total is 1,200. Let's count people who are underclassmen or people who've seen the film. Do these people count? No. Do these people count? Yes, because they've seen the film. Do these people count? Yes, because they've seen the film and they're underclassmen, so they count like at least as much. Do these people count? Yes. Why? Because they're underclassmen. They haven't seen the film, but they're not seniors, they're underclassmen. So I'm going to add them as well. Again, if you don't like it that way, just do it as one plus another minus both. That'll work as well. It's up to you. I think it's going to be most of the people here. So it's a pretty strong chance of this happening. What is that? 360 plus 830. Don't want to grab my calculator and being lazy. 1190. I mean, it's all but those piddly 10 people who are seniors and have not seen the film, right? So it's pretty much 90 what? 99.1? 99.1 or 2? Okay. So there we go. There's another example of compound probabilities. It's all about the Venn diagram. See you next time.